Delegates. Wouldn't it be great if we could call events and functions and stuff? That's basically what delegates are. All right, let's go make ourselves delegate. Declare delegate. There's already, I will say that for the delegate stuff, there's already like some pretty good tutorials online, I think, for this stuff. So I'm not going to go too in depth, but we'll cover it quickly. So we can make a delegate. We can call this. I'm not going to call it F delegate because that's already a thing. F my fancy delegate. And let's say it takes an int. And then we can say I want my delegate, and we can create this and we can create a delegate and bind it in one hit. So you can also use if my delegate was like a field, like you could do my delegate dot bind to bind it to something. In this case, we're just going to do create. You can bind this to a variety of different places. You can bind it to a lambda, which is a C++ lambda. Right, so we can do this. You can bind it to a raw function, which is like a raw C++ function up here. I'm pretty sure this is what that is. You can just bind it to a raw function. Oh, whoops, bind to a raw function. That's going to complain about me. I don't really use create raw too much, I'll be honest with you. The ones that you actually probably care about is create lambda, create weak lambda, create UObject, and then create SP, which is shared pointer. There's also create thread safe shared pointer. If your shared pointers are thread safe, you need to use this instead. I just realized I didn't cover thread safe shared pointers at all in the other session. By default, shared pointers are not that all that T shared pointer stuff we were doing. I don't have a class anymore, but I'm just going to pretend like I do. Like it's not threads like that. This T shared pointer is not thread safe. You can't like read and write to it from multiple threads. You can declare it thread safe though by doing ESP mode thread safe. And you will see this a lot on in like the online subsystem APIs because there's lots of network calls. The Steam online subsystem, for example, does everything in the background on the background thread. So you'd see thread safe there quite frequently. That's just something to note. So if you're doing a thread safe pointer, or if your object is a thread safe, if your object is stored in a thread safe shared pointer, then you need to use create thread safe SP. Other than that, these kind of do what you expect. So with that, create a UObject. Let's go to our let's make a handler. So we're going to call this void handler int b, and we create a UObject, and we're going to say this a test project game mode base. Right, let me go make this a bit more readable. Cool. So now we're creating a delegate, and the delegate is bound to the handler, this function here, the address of this handler, on this instance of the thing. And then we could call this, we could do, this is just a single target delegate. So we have execute and execute if bound. We can pass 10, 20 here. Remember, we need to implement our functions. This will still compile, I would expect. Well, sorry, the C++ will compile. The linker will be very annoyed at us because it doesn't actually have the implementation. But if we go and define this, then B here would be 20 because it'd be called via this handler, and it'll be quite happy. So we've talked about declare delegate. You can specify how many parameters you want. If you want 5 parameters, all up to 5 parameters. For single target delegates, that is delegates that can only be bound to one function at a time, you can also specify that they should have a return value. So if we want a function that takes an int and returns an int, let me try to fix up I think this is how you would declare it. you'll notice now that obviously, well, the create UObjects can complain because this doesn't actually have an int return. If we change it to an int return, now this will be happy. You'll notice we can't call execute if bound anymore. That's because we have a return value that we need to have. So, and your code needs to be aware of, like, if it's not bound, then what are you going to do for the return value, right? So in this case, like, if you were to call this and if the delegate wasn't bound, right, like if I just did this and it's an unbound delegate, or if I was to, you know, do this and unbind its target, then this would assert because it has nothing to call. And so to avoid that, you do is bound, right? And so then that way, you know, if it's bound, you can handle it, call it, use its return value. Otherwise, you can, you know, do something useful that isn't crash the program. And cool. So that's return values in your single target delegates. Let's do multicast delegates. So multicast delegates, they can't have a return value because they can have multiple bindings. So let's just fix that up. Now what we can do, so you can't do create UObject anymore, but what you can do is you go my delegate, add UObject, and then you can say this handler. And now when we call my delegate, instead of calling execute, we don't have execute anymore. Instead we call broadcast, and this is complaining about my fancy delegate. If delegate create UObject. I'm just going to do it this way because this is the way I normally do it, actually. What's it complaining? Oh, it's complaining because the return type is still wrong. Yeah, there we go. You can just add a delegate. So in a multicast delegate, if you want to add, like, you know, like if I want to do create SP, like a shared pointer, whereas this is a shared pointer, you can do it this way. So you like create the shared pointer delegate by accessing this F delegate, and that returns a delegate that you can then add. Or you can just add it directly, apparently. Yeah, so you can add all of these just directly and then just bypass that that extra indirection call. So we can just add it here. If we had multiple handlers, and these obviously these handlers can be on multiple objects. They can be wherever you like. When you use add UObject, the event handler is smart enough to know that if the UObject goes away, I hope you can't hear that car alarm going off outside. When the UObject goes away, like say it's bound to an actor, right, and the actor is destroyed, the event and delegate system is smart enough to not call the handler on things that have gone away, right? So because it's aware that's a UObject delegate handler, it will basically just go, well, the actor doesn't exist, I'm going to skip. And that's the same thing, like if you go add weak lambda. So if we wanted to do, say we wanted a lambda, right? So we didn't want to have to define this whole extra separate function up here. We just wanted to do an inline thing. It's not safe when you're doing UObjects, right? If you were to bind it, like if we would just use add lambda, let's use this as an example, right? We do add lambda, we pass this pointer in, this pointer gets captured in the lambda. The thing is that the delegate has no awareness of the lifetime of the UObject here, right? It has no reference to the UObject. So it will continue to call this lambda beyond the lifetime of the UObject. This pointer that's being captured here is only aware at the lambda, like C++ level, which has no awareness of the garbage collection system or anything like that. So we use weak lambda and pass to this pointer, and then that way the delegate system knows that when this UObject goes away, when its lifetime is gone, that this lambda is no longer a valid target to call. So that, you know, if you've got like this dot, well, I don't have any fields, but, you know, if I had a field on it, you wouldn't run this code because the pointer doesn't exist, because the UObject doesn't exist, because it's gone. Yeah, so anyway, you can add multiple targets onto these delegates, and then you can call broadcast, and every single one of these bound delegates will get an invocation. And so that's sort of how you can do events. I'm just going to catch up on chat real fast, because it seems to be I might actually ask Liam at the end to sort of filter through some of that so I can keep going. So that's delegates and multicast delegates. Now, there's one other thing that we need to cover, which is dynamic delegates. And there are both dynamic delegates and dynamic multicast delegates. Oh, excuse me. Dynamic delegates are used with blueprints. They're slower and they're used with network calls. They're slower than normal delegates, but they have the advantage that they're serializable and they can be looked up by name. So when blueprints are like resolving events or when network stuff's happening, you can just look them up by their name, which is useful for that sort of remote RPC functionality that Unreal has. Other than that, they're basically the same. The format is slightly different in the sense that you do have to give names for the parameters. So like, why is this not working? Yeah, if you have questions, just at me, and then I will respond to them. I'm pretty sure that should compile. Why is this having a not great time? Excuse me. Am I missing something off this? Oh, that's not gonna work. Do I not have... Yeah, that's all reasonable. Someone in the chat asked, are there things we should look out for regarding delegates and multi-threading? So you're only going to be doing multi-threading, or you're really only going to be doing multi-threading if you're working at that like shared pointer level, right, that I was talking about earlier. I do not believe that it is safe to do UObject stuff with multi-threading. I could be wrong, but I believe that that's not safe. And that your UObjects are typically like game thread related stuff. Your UObjects might call into like lower level code that is then doing harder work on the threads, but the UObjects themselves are not multi-threaded. And then, so then in the case where you are doing like T-shared pointers that are threads, or they need to be thread aware, then you want to be using those thread safe shared pointers, right? If you can be modifying those shared pointers from any location, and if you're calling events and delegates on those shared pointers, you should be using the create thread safe SP function, and you should be using the SP mode thread safe for those shared pointers. I'm going to be perfectly honest with you. I'm not quite sure why this is. You know what I'm going to do? I'm just going to go and get an example from the engine itself. By the way, Control-Shift-F, when you want to know how something works in IntelliSense, is kind of just like not giving you what you want. Control-Shift-F is like the best thing you can do. It's like, I want to know where all of the delegates, the dynamic delegates with one parameter are declared in the engine, and you just like go and look at all of them. And now we can look at all of them. So you see, here's an example. I don't know why IntelliSense is not happy with me. Maybe it wants to be in the header. Maybe that's what it is. Where'd our header go? Oh, our header's sitting over here, chilling. This work? You know what? That makes a lot of sense, because this probably is parsed by the Unreal header tool, and it's generating stuff in here for us. I wonder if we can actually see it. Oh yeah, it is too. Look, see, we can see here on line 10, delegate. Here's all the extra stuff that I need for my delegate. That makes a lot of sense, because they're serializable. They have names. You need the metadata to look them up. Here's all of the stuff that does that registration for us. And it goes in here. So that's probably why we have to do our declare dynamic delegate inside the header file, because it's not going to look at the CPP files for those declarations. And then because, if we go over here, we put it in here, and if we were to look at what these macros expand out to, it's going to be trying to expand out to like, the stuff, whoops, the stuff that is in this generator header that doesn't exist because there's not going to be a define for like underscore CVP at line whatever. So that's why we get errors there. So you got to put these in the header file. So yeah, dynamic delegates, blueprints, networking, also multicast delegates. Cast delegates. I think it's dynamic multicast delegate, I think. Yeah, dynamic multicast delegate. And ooh, I don't want to do that. And then we can have multicast delegates, which is the same thing. Oh, you're gonna complain at me because I did that. Yes. All right, and they basically work the same, and you can use them in blueprints and stuff. There are also U function blueprint implementable event, and I'm gonna have to remember off the top of my head how we do this. So please bear with me. Which is I think it's yeah, I think this is it. And so now if we were to like derive, if we in the editor, if we were to create a subclass or a blueprint class based on this game mode base that we've made, we could implement this event in the event graph. And then our C++ code, like let's say we just go into here and we're like, cool, I want to call this implement me, right? And then this would call into the blueprint code that we've defined in our base class, and it all just sort of works. You can also do blueprint native event, and I believe the way that this works is this lets you have an event in that you can override in blueprints, but it also has a parent implementation, right? So we have a default implementation. I don't know if this is semantically. I don't know if this is synaptically correct with the underscore implementation. It is too. Cool. Now, what's happening here is basically, so we can have our blueprint override of the event. We can call into the parent of that from our blueprints, which will call this native logic. The reason that we've got this underscore implementation is that when we call implement me, we want to have Unreal call the blueprint logic, which then the blueprint logic can call implementation. The reason where this is defined, right, where this function is defined, is generated body. So generated body will expand out to a macro that, let's go look at the thing. It might not be directly in line here. It might be implement me. Yeah, so here we go. This is where it's inserting this into the header for us. It's saying there's a virtual implement me implementation, and then we can go and override it in our native code to do what we want. A question is, can you go over functions that can input delegates? You mean functions that take delegates as a parameter? Is that what you mean? Declare delegate one param if my delegate int. I'm going to put this in the header actually. Yeah, so if we wanted to have void func that takes a delegate b, and so let's go handler. I apologize for using b everywhere. Handler begin play. So we can call this func that takes a delegate if my delegate create UObject this address of handler, and now we're passing the delegate in as a parameter to func that takes the delegate, and then this could be like more readable, f dot execute 20, and then this would have 20 passed in here. Does that sort of answer the question? That was, can you go over functions that can input delegates? Yeah, okay. Yeah, so this is basically how you can do it. Oh, something I should point out. You want to save yourself a copy? Put your const ref in. You'll save yourself a copy. Oh, I need to go update the header as well. Actually, this is a good segue into more delegate stuff that I didn't have on my list, but it's actually really useful to know. So let's say we have a delegate. It takes an int, a single int, and what we want to do is we want to pass some extra information in, where that extra information is defined at the point that we're binding. So let's say we wanted handler to take in an f string as well. Right? Now the event is not providing this f string, but when we bind it, we want to propagate an f string through to the call site, right? So what this lets us do, hello, right, is basically make sure this is. Why is this not happy? Oh, I need to, because this is all like templated stuff, you have to make sure that the types match exactly. It will not do like the implicit conversion to f string for you. It will just complain at you. You're like, gotta do this. So now what we've done is, excuse me. Is we've created a delegate. We've bound extra information on that delegate that is not actually part of the delegate signature. And this is useful when we want to like propagate information through that we know when we're binding all the way through to the point where the delegate is then being called later, and we can get that information out and be like, oh, cool, that information came from where it was bound, and we can do things based on it, even if we didn't have the necessary parameters or the necessary fields to propagate all the way through the delegate itself, through whatever code is calling that delegate. Now you could do this another way. You could create a lambda that then calls, you bind a lambda and then put all of the extra payload in the lambda and have the lambda call your function with extra parameters. But you can just as easily do it this way, where you declare the extra parameter on, or multiple extra parameters on the handling function, and then you just pass the extra parameters after the handler. There is one catch. There is one catch. Remember how I've been telling you this whole time? You can put like const ref on things and save yourself a copy. If I go here, this will compile. Oh, maybe it won't compile. Hang on, let me see if I can get it to compile. You're gonna be not playing nice to me. Why? Const f string ref. Oh, you can imagine maybe this will work. I don't know why that's throwing his fit at me right now, but just to illustrate the point, if you do happen to get an invocation here where you've got a const ref parameter coming in as a payload, you have to be aware that this is going to break horribly. Because if you think about where the const ref is, right, what the const ref is actually pointing to, the const ref is pointing to this, like in this case, it's A on the stack. There might be a parameter that comes in the stack, but the delegate is not making a copy of this f string anymore, right? It's just holding a reference. So by the time the delegate gets called, which could be way down the call stack, it could be, in a different frame, the reference is gone, right? And so now your const reference that looks to be perfectly fine is actually just pointing to garbage memory, and you'll just crash. So it's really important to understand that if you're going to pass extra parameters to delegate, like if you're going to use this like user payload stuff in delegates, is that you actually do want to pass by copy. You don't want const reference, because you need the delegate to capture it as a copy, so that when it's called 10 frames from now, that you actually have the copy on hand and can use the data. You don't want to be using references. This is something that caught me out a few times and had a few like weird subtle crashes, and I was like, why is this causing it? And it can be really invisible too. Like if you've just gone here and you've just made this a const ref, and like you just have code that just looks like this. Imagine this isn't complaining about anything, and you're looking at this and you're like, why is this crashing? Like, what is the problem here? And it's because the delegate is capturing the reference, not a copy of the thing. And so the memory, when it comes time for, because it'll crash here, like it'll crash at the point that's broadcast, like actually calling the delegate, and you'll be like, what? Or it'll crash inside the handler when you're trying to access C, and you're like, why is C like total garbage? And it's because it is a const ref instead of being an intentional copy like we want it to be. Because delegates can last across the lifetime of the current call stack or the lifetime of the thing that you passed in. How are we doing with time? Oh, we're pretty much bang on time. Excellent. Were there any other questions about delegates and stuff before we take our afternoon break? In the chat, don't use const ref with delegates. Totally fine to use const. In fact, you should use, if this was a class, like if this was an F string, you should use a const ref for this thing here, right? You should use const ref for the delegate parameters that the caller of the delegate is responsible for passing, because the caller here, well, it can pass in, you can pass in a const ref here. It's totally fine because this is in the call stack, right? This execute is then going to call a bunch of functions, but this is still on the call stack, so it's totally fine. This is a const reference. You just don't want to use const ref for the user captured parameters, which may live across multiple frames or scopes. I thought I would just clarify that. All right. Well, that's going to be the end of this session then. If you have time, can you talk about delegate handles? Oh, yes, actually, that's a very good point. We should talk about delegate handles. Sorry, we'll come back. All right, delegate handles. Excellent. Right, so we are going to make a multicast delegates one param f my delegate int, and we're going to give our You know what? I'm going to keep this F string here for illustration purposes. So let me just clean up some of the other stuff though. Right, cool. So let's say we add a UObject to, we add a binding to a multicast delegate. We want to, no, I just have to do this thingamajig here. I'm going to pass in an F string. Right, and then we add another one, right, and now we want to unbind one of these, right? How do we know which one to unbind, right? Well, for multicast delegates, for multicast delegates, you get an F delegate handle back, right? And then when you want to unbind a particular binding to a multicast delegate, you basically go, oops, that is not what I wanted, autocomplete. And then you go remove binding and you pass in the handle. And now, after this code runs, only the second one will remain bound to the multicast delegate. And so that's how you can manage your bindings on multicast delegates. This is very common on, if you're doing anything with online subsystem, you will like bind to like an event and be like, when I say event, I mean multicast delegate, bind to an event, store the delegate handle. When you get the callback, you then go, okay, I'm not interested in the event anymore. And then you just remove it off the event so you don't get it firing more than once. Yeah, and so add timers also use this as well, which I didn't cover. So if you want to add something, you can do git core ticker, add ticker, f ticker delegate, create UObjects. This, oops. Let's make this compatible with ticker. Grab this. We'll just set the delay to nothing. And so if you were using tickers, handle of tickers return bulls. And we go here, we go work delta time. So now we've got our, ticking function. You return false to not continue running the tick. You return true to keep it ticking. So you can obviously choose whether or not the ticker remains running from inside the handler. But then you can also stop it being bound at any point by going roof ticker and then passing in the delegate handle that you got back from at ticker. And get core ticker is just like the global ticker that you can use if you've got any arbitrary stuff you need to run on tick that doesn't fit within the other patterns. Like here, obviously, we're doing game mode based, so the sensible way to do things would be to override the tick function. But particularly if you're in low level code, you might not have a tick ready available, so you can just use the core ticker instead to do that. Cool. All right. Now I think we've covered everything.
Yeah, and sorry, June, just to clarify, there was just a really good discussion happening earlier when you sort of had a bit of a look there. It was just some things around UObjects and outers and how they interact with the garbage collection. So there's a couple of the members that are going back and forth, which you did touch on and you sort of covered, and some just general approaches to learning this stuff and where this is at. Would you say it's safe to classify this workshop as like intermediate to advanced stuff? Would you?
I would say everything that I've talked about in, I think, well, the high level stuff, like the delegates and stuff, you're probably going to interact with delegates if you're just doing like high level gameplay code. The shared pointer stuff that I talked about earlier, that's a bit more intermediate. Like if you're doing low level code, you're going to run into that because you're not going to be purely dealing with UObjects. And then, I mean, the foundational sessions are like, I would rate the foundational sessions, the first 3 talks that I did. They're actually probably harder than a lot of this stuff, but you kind of have to know them regardless of what you're working in. So.
Yeah, no, yeah, absolutely, and I think that was some of the consensus that was reached in the chat that just to help people that maybe might not be as advanced, like how would they contextualize this information, like how should they sort of be approaching it? So that's really great to know.
Yeah.
But no, that's really great so far. I'm excited. After the break, we got a bit of a break here.